Welcome to Godwills, talent hub.
What if I tell you that the numbers
Where
you use
talent
every day
meets
hold secrets that
opportunity.
power your bank account security,
Discover
create
your
music,
potential,
and even many more
ignite
things to
your
survive?
passion,
Stay tuned because by the end of this
shine with
video,
us.
you will see
Let's
numbers
create
in a completely different
greatness
way.
together.
Hey everyone, welcome back to Godwills Talent Hub. This is Satish, and today we are diving deep into the fascinating world of number types. We are talking about even, odd, prime, composite, co-prime, and twin primes. And trust me, this is not your boring math class. We are going to explore why these numbers actually matter in your real life. If you're ready to unlock the secrets of mathematics, smash that like button and subscribe for more mind-blowing content. Let's get started. All right, let's start with the basics. Even numbers. Now, you probably think you know what even numbers are, but let me blow your mind with how they actually work. Even numbers are simply numbers which are divisible by 2 without leaving any remainder. Simple? Right. But here is the formula that mathematicians use. 2 times n, where n can be any integer, 0, 1, 2, 3, and so on. Look at these examples on the screen. You see 2, 4, 6, 8, 10, 12, and did you notice something over there? They all end in either 0, 2, 4, 6, or 8. That's your quick identification trick. All right. Now look at the properties, which are like these. These are the 3 powerful properties that you should remember. When you add an even number with any even number, you will get even. And when you subtract an even number from an even number, you will still get uneven. And when an even number is multiplied by any other even number, you will get the same even. It's like even numbers have this magnetic pull to stay even. All right. Now let me quickly ask you a question. Pause the video and tell me in the comment section, is 0 an even number? I'll give you the answer during our session. All right. Now let's talk about odd numbers. These are called the rebels of the number world. Odd numbers are not divisible by 2. When you try to divide them by 2, you always get a remainder of 1. And the mathematical formula is same like even, which is 2 times n, but there is a plus 1 to it. So that plus 1 is what makes them odd. Check out these numbers on the screen. 1, 3, 5, 7, 9, 11, 13, and so on. They all end in 1, 3, 5, 7, or 9, which is another quick identification trick for you. And coming to the properties, here is what it gets interesting. When you add an odd number with another odd number, it becomes even. And when you subtract an odd number from an odd number, you will get even again. But when an odd number is multiplied with another odd number, it stays odd. They are stubborn like that. Think about it. Why do we have odd one out? Because odd numbers are literally different from their even neighbors. Right? Okay, let's put these 2 number families head to head in an epic showdown and understand how exactly they are different from each other. Look at this comparison table. Even numbers are divisible by 2, but odd numbers are not. Even numbers end with either 0, 2, 4, 6, or 8, whereas odd numbers end in 1, 3, 5, 7, or 9. And the formula for even number is simple, that is 2 times n. And for odd, it's same like 2 times n, but a plus 1. It's like odd numbers are even numbers that went just one step further. And here is that answer I promised earlier. Yes, 0 is an even number. Why? Because 0 divided by 2 equals 0 with no remainder. Perfect. Now let's get into our next topic, that is prime numbers. So these are called as heavy hitters. These are also considered to be the celebrities of the math world. And you're about to find out why. Prime numbers are called the building blocks of mathematics. And they are literally protecting your online banking right now. But more on that later. What exactly you know about prime numbers? A prime number is a natural number greater than 1 that has exactly 2 factors, 1 and the number itself. That's it. It's like an exclusive club with strict membership rules. Here is what makes prime special. It has exactly 2 factors, no exceptions, must be greater than 1. That's why 1 is not a prime number. The number 2, the only even prime. It's the unicorn of prime numbers. All other primes, they are odd. And here is the crazy part. There are infinitely many prime numbers. Mathematicians proved this over 2000 years ago. Take 7 for example. Can you divide it evenly by anything except 1 and 7? No. That's what makes it prime. Let's look at the first 25 prime numbers on the screen. Look at how they are spread out. 2, 3, 5, 7 till 29. Did you notice something? After 2, they all are odd. The number 2 is special. It's the only even prime standing alone in its uniqueness. As these numbers appear on the screen, pick your favorite prime number and drop it in comment section. Mine, I love 17. And here is our next set of 25 numbers, prime numbers. So look how they get more spread out as numbers get bigger. The 50th prime number is 229. Think about that. We had to go all the way to 229 to find just the 50 primes. They become rarer and rarer, like finding diamonds as you dig deeper. The fun fact, the largest known prime number has over 24 million digits. Imagine trying to write that out. Now, if primes are the celebrities, composite numbers are the popular kids. They're everywhere and they have lots of friends. A composite number is any natural number greater than 1 and has more than 2 factors. Basically, if it's not a prime number and it's not 1, then it is a composite number. Here is what makes composite special. More than 2 factors, the more the merrier, can be divided evenly by numbers other than 1 and itself. Every composite can be broken down into prime factors, and we call this as prime factorization. We'll discuss more on the upcoming videos on this prime factorization. So the smallest composite is 4. Take 12 for example. Its factors are 1, 2, 3, 4, 6 and 12. That's 6 factors. And look at this. We can break it down as 12 is equals to 2 times 2 times 3. We just expressed a composite using only primes. That's the power of prime factorization. And especially when you're trying to find out the LCM and HCF, we use this prime factorization method as the best method to find them out. All right. Now let's look at the first 50 composite numbers. So on the screen right now, we are able to see the first 25 composite numbers, 4, 6, 8, 9, 10, 12, and so on. But wait, where is 1? Here is a super important fact that many people get wrong. 1 is neither prime nor a composite. It's in its own special category because it has only one factor, that is itself. So remember, 1 is the lone wolf. It doesn't belong to any pack, the pack of primes or the pack of composite. All right. Now here are the next set of composite numbers, that is still 50. So you see these numbers are actually ending at 70. Notice how most numbers are actually composite. Primes are the rare gems. Think about it. By the time we reach 70, we have found 50 composite numbers. But to find 50 primes, we have to go all the way to 229. Composites are way more common. All right, now let's look into the comparison between prime and composite. So let's settle this once and for all. Primes versus composites. Factors. Primes have exactly 2, whereas composites have more than 2. And the smallest prime number is 2, and the smallest composite number is 4. Examples of primes are 2, 3, 5, 7, 11, 13, and so on. Composites are 4, 6, 8, 9, 10, 12, and so on. Primes are only divisible by 1 and themselves. Composites, they are divisible by multiple numbers. But here is the key point that connects everything. Every composite number can be expressed as a product of prime numbers. It's like primes are the DNA of all composite numbers. This is called the fundamental theorem of arithmetic, which you can experience in your class 10th. And it's one of the most important concepts in mathematics. All right, now we are entering into the advanced territory, co-prime numbers. This is where math gets really cool. The numbers are, two numbers are co-prime, also called relatively prime, if their greatest common divisor, that is the HCF, is 1. In other words, the only factor they share is 1. Here is what's crazy about co-primes. The numbers themselves don't have to be prime. 8 and 15, both composite, but they are co-prime. Any two consecutive numbers like 7 and 8 or 99 and 100 are always co-primes. All prime numbers are co-primes to each other. They share nothing but 1. The rule is simple. If HCF or the GCD of two numbers like A and B is 1, then A and B are called as co-primes. That's it. Let me show you 3 examples that will make this crystal clear. First up, 8 and 15. Factors of 8 are 1, 2, 4, and 8, whereas factors of 15 are 1, 3, 5, and 15. What do they share? Only 1, that is the HCF. So they are co-primes. Next, 9 and 16. Factors of 9 are 1, 3, and 9. And factors of 16 are 1, 2, 4, 8, and 16. The only common factor, what they have, is 1. They are again co-prime. But look at this, 12 and 18. Factors of 12 are 1, 2, 3, 4, 6, and 12. Factors of 18 are 1, 2, 3, 6, 9, and 18. They share 1, 2, 3. Therefore, their HCF is 6. So they are not co-primes. The HCF should always be 1 among those two numbers. Like when we calculate the highest common factor of those two numbers, it should be always 1. Only then those numbers are called as co-primes. And make sure to remember, it is not mandatory that both the numbers or at least one number should be a prime number. They can be anything. If they share a common factor, then they are not co-primes, except one. Perfect. Here is your pro tip. Any two consecutive numbers like 5 and 6 or 23 and 24 are always co-primes. This is a quick check you can use. Now let look at the co-prime pairs. Look at all these beautiful co-prime pairs on the screen. 2, 3, 3, 4, 5, 7, 8, 9, 11, 13. See any patterns? Many of these are consecutive numbers. And notice how even composite numbers can be co-prime with each other, like 14, 25, and 27, 35. These co-prime numbers are used in music theory, cryptography, and even random number generation. They are more useful than you might think. Now let's get into the twin primes, the final concept. And this one is so cool. Welcome to the world of twin primes. Twin primes are the two prime numbers that have a difference of exactly 2. They are called twins because they are as close as two odd primes can possibly be. For numbers to be twin primes, both must be prime and no composites are allowed. The difference must be exactly 2. The form is P and P plus 2, where both are prime numbers. Examples: 3 and 5, 5 and 7, 11 and 13, 17 and 19. And here is the unsolved mystery. Are there infinitely many twin primes? Mathematicians believe there are, but nobody has proven it yet. It's called the twin prime conjecture, and it's one of the biggest unsolved problems in mathematics. Look at this twin prime pairs up to 200. 3, 5, 5, 7, 11, 13, 17, 19. Notice how they get more spread out as numbers get bigger, but they keep appearing. 197, 199, 2 primes separated by just 2, way up at 199. Do they go on forever? If you can prove it, you will become famous in math world. Someone might be watching this video right now who will solve this mystery. Let's talk about some special properties and mind-blowing facts. First up, the number 2. It's the only even prime, the smallest prime, and it's the most unique prime number in existence. And there is 1, the rebel. It's not prime, not composite. It's in its own category with only one factor, itself. Math has special exceptions, and 1 is the biggest one. Here is another unsolved mystery. Goldbach's conjecture. It says every even number greater than 2 can be expressed as the sum of 2 primes. For example, 10 can be written as 3 plus 7, where 3 and 7 are prime numbers. 14 can be written as 7 plus 7, which again they are prime numbers. 20, 13 plus 7, which again are the prime numbers. So nobody's found a counterexample, but nobody's proven it's always true. And finally, the fundamental theorem of arithmetic. Every integer greater than 1 can be expressed as a unique product of prime numbers. For example, 60 can be written as 2 into 2 into 3 into 5, which is again written as 2 square into 3 into 5. This is why primes are called the building blocks of mathematics. Let's put it all together. Look at numbers 1 through 30 and see how they are classified. Gray is 1, neither prime nor composite. Green are the primes, 2, 3, 5, 7, 11, 13, and so on. Orange are the composites, everything else. And see how primes get more sparse. That's the pattern of mathematics. Every single number fits into one of these categories, no exceptions. That's the beauty of mathematical classification. Now, for the really cool part, where do we use all of this in real life? You're about to be amazed. Cryptography. Remember how I said prime numbers protect your bank account? Here is how. The RSA encryption, the security behind online banking passwords and secure websites, is based entirely on large prime numbers. When you see the padlock on your browser, that's prime numbers at work. Computer science, hash tables, the data structures, algorithms use prime numbers for optimal performance, and your computer runs faster because of primes. And the music theory. Music, co-prime numbers create interesting rhythmic patterns. Composers use them for polyrhythms and complex time signatures. That catchy beat could be co-primes. And even in statistics, co-prime numbers are used in sampling methods and random number generation. When scientists conduct studies, they are using these concepts. And even art, even in odd patterns, create visually symmetry and balance. Designers use these patterns to make the things pleasing to the eye. So the next time someone says, "When will I ever use this?" you can tell them literally everywhere. All right, friends, let's wrap up this session with the key takeaways. You need to remember even numbers divisible by 2 and they're in the form of 2n. Odd numbers not divisible by 2 and they're in the form of 2 times n plus 1. Prime numbers, exactly 2 factors, 1 and itself. Composite numbers, more than 2 factors. Co-prime numbers, the highest common factor is 1 and they do not share any common factor apart from 1. Twin primes, prime pairs with a difference of exactly 2. Understanding number types isn't just about passing a test, it's about understanding the fundamental language of the universe. From nature to technology, from music to security, these numbers shape our world. If you learned something new today, smash that like button, subscribe to Godwills Talent Hub, and hit the notification bell so you don't miss out next video where we will dive even deeper into the mysteries of mathematics. And drop in the comments your favorite number type, which real-world application surprised you most, any questions you have about numbers. Thanks for watching. This is Satish from Godwills Talent Hub. Remember, numbers aren't just symbols on a page. They are the secret code to understanding everything around you. See you in the next video. Keep calculating, keep curious.